Alright, so we're going to be solving quadratics by completing the square in this video. This is a little bit of a weird topic, and a lot of people don't really find too much of a use for it, except that there are two really wonderful practical applications of using completing the square. So you're going to have to bear with me for a minute. The first thing you need to do is make sure that it's set equal to 0. Your quadratic is set equal to 0. You could do this one by factoring, but we're going to do this the way I was intending. And then you need to identify your A is 1, your B is a -4, and your C is a -5. The key one that we're really interested in is B equals -4. And I'm actually going to get rid of these other two, and I'm going to show you something else. If B equals -4, that means B over 2 equals -2. And that means that B over 2 quantity squared equals +4. And no, that's going to make sense in a minute. So what you do when you're completing the squares, the first thing you do is you move C over. Oh, and I should say this is when A equals 1. The next thing you do is you take half of B and you square it, which is this one right here, and you add it to both sides. And so I got x squared minus 4x plus 4 equals 5 plus 4. And that seems like a weird thing to do, but the reason why is because now you can write this trinomial as a perfect square binomial. And what it is it's going to be x plus b over 2. So let's see if I can do this with some color. This is here. And then once you do that, this goes here. So I'm left with x minus 2 quantity squared equals 9. I'm going to take the square root of both sides. And so I got x minus 2 quantity squared equals 9. Now, when you take the square root of both sides, this has to become plus or minus. And now I'm left with x minus 2 equals plus or minus, well, it's actually 3 now. I'm going to add 2 to both sides, and I get x equals 2 plus 3, or x equals 2 minus 3. So x equals 5, or x equals -1. The steps here are a little bit tricky, and I am aware of that. So I'm going to give you another example. In this example, a does not equal 1. So the first thing I'm going to do is I'm going to move over my c. That's actually the first step always. And that's supposed to be a 2. So when I move my c over, I get 2. Now I'm going to divide everything by 6. Well, when I do that, I get x squared plus x over 6 equals 2 over 6. Now my b is 1/6. My b over 2 would be 1/12. And my b over 2 squared would be 1/12 times 1/12, which is 1/44. And that's what I'm going to add to both sides. I got x squared plus x over 6 plus 1 over 144. Goodness me. 1 over 144 equals 2/6 plus 1 over 144. And now I can write this as my perfect square trinomial. It's going to be x plus 1/12 squared equals, oh goodness me, I'm going to have to do a little bit of work over here. Let's see. 6 goes into 144 how many times? 2, so it's going to be 24. So that's going to have to be 49 over 144. I get that because I'm going to have to multiply this by 24 over 24 to get a common denominator. And 48 plus 1 is 149. So now I take the square root of both sides, and I get x plus 1/12 equals plus or minus the square root of 49 over 144, which oddly enough, those are both perfect squares. And then subtract 1/12 over, and I'm going to end up with x equals negative 1/12 plus 7 over 12, because square root of 49 is 7, square root of 144 is 12, or x equals negative 1/12 minus 7/12. And I'm going to write my final solution. I'm going to rewrite everything over here because now it's a big mess. So I have x equals negative 1/12 plus 7/12, which is x equals 6/12 or 1/2, or x equals negative 1/12 minus 7/12, which is negative 8/12. So x equals negative 3/4. And that's it. That's using the difference of perfect squares. Like I said, it does have two applications which are really, really useful. And one of them is for circles, and the other one is for graphing quadratic equations. And so that's where I'm going to leave you for now. It is a little tricky. Go through the video again and write down the steps, because that should really help.